Number 11 tests your knowledge of what the first and second derivative mean and what they tell us about the graph. So here's the graph of f of x, and we want to know what is the sign, is it positive or negative? What is the sign of the first derivative if the x value is negative 7? Essentially, we're asking about the slope of the tangent line. Is it positive or a negative slope? So let's label negative 0, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7. So here's the point on the graph at x equals negative 7, and the tangent line would have a negative slope. So the sign of the first derivative at negative 7 would be negative. What about the sign of the second derivative at negative 7? Would the output be positive or negative if we put negative 7 into the second derivative? Remember that the second derivative tells concavity at that x value. So at negative 7, is the graph concave up or concave down? And I would say that the graph is concave down. If the graph is concave down at a value, then we know that the second derivative would be negative. Alright, let's look at negative 5. Here is the point on the graph at x equals negative 5. And the first question is asking us about the slope of the tangent line. So here would be the tangent line. And it looks like the slope there is going upward. The line is slanting upward, so that would be a positive slope. So if we put negative 5, that x value, into the first derivative, the slope will come back positive. Now what about the second derivative? It looks like at that point on the graph is concave down. So if we're concave down, then of course the second derivative will come back negative. And this is part D. Alright, now we're looking at the first derivative. So this is part E. Looking at the first derivative at positive 7. So 1, 2, 3, 4, 5, 6, 7. So at this point right here. Okay, first of all, what is the slope of the tangent line? It looks like the tangent line is slanting downward. And the first derivative tells us the slope, so the slope at that point would be negative. Okay, the second derivative, if we put x equals positive 7 into the second derivative, that would tell us the concavity at that point. It looks like the graph is concave up at x equals positive 7. And we know that if the graph is concave up, then the second derivative will come back positive at that point. Okay, what about positive 5? So at positive 5, the graph is right here. And looking at the tangent line, looks like the tangent line is slanted up. So the graph is increasing there. So the slope would come back positive. That was F, and this is G. And then H, we're looking at positive 5 again. Is the graph concave up or concave down at positive 5? And I would say it looks like the graph is concave up. And if the graph is concave up, then we know that the second derivative at that point would come back positive. Okay, the last two questions are asking us to find the coordinates, so the x and y values, of any relative minima and any relative maxima. So where do we have relative max and relative mins? So the points that look like they're the highest or the lowest points of anything around it. So I would say this part right here, this point, negative 4, looks like a y value of 2, would be a relative maximum. And this point here is lower than any point around it. Negative 1, comma negative 3. This would be, I would say this looks like a relative minimum. And over here the graph is increasing and continues to increase, so we do not have a relative max or a min there. But there's a point right here at the very top of that little point, 6, comma 3. and that looks like the highest point of any point around it. So that would be a relative max. Alright, so let's write that down. Relative max would be at -4, 2, 6, 3. So we have 2 points that we could call a relative max. And then a relative min occurs at -1, -3.